Human brain versus supercomputer. Who will win? It's a curious question. Since the birth of the first computers, there has been a direct comparison between calculating machines and the human brain. One popular comment in the brain versus computer argument is that brains are analog, computers are digital. This makes it seem as if computers are superior, but the truth is that the human brain is much more advanced and efficient and has more raw computing power than the most impressive supercomputers ever built. At the time of this writing, the fastest supercomputer is Qianhe 2 in Guangzhou, China, with a maximum processing speed of 54.902 petaflops. A petaflop is a quadrillion floating point calculations per second. That's a huge amount of calculation, yet that doesn't even come close to the processing speed of the human brain. In fact, our miraculous brains operate on the next order. Although it is impossible to calculate precisely, it is postulated that the human brain operates at 1 exaflop, roughly 1 billion calculations per second. When we talk about computers, we refer to carefully designed machines based on logic, reproducibility, predictability, and mathematics. On the other hand, the human brain is a confused, seemingly random jumble of neurons that behave unpredictably. Biology is a beautiful thing, and life itself is much more complicated than computers. Thus, the brain is both hardware and software. The same areas connected by billions of neurons and perhaps trillions of glial cells can simultaneously perceive, interpret, store, analyze, and distribute. By their very definition and construction, computers have some parts for processing and others for memory. The brain does not make this separation, which makes them enormously efficient. The same calculations and processes that a computer might need a few million steps to complete can be accomplished through a few hundred neuron transmissions, requiring much less energy for a more efficient result. Biological organisms have taken billions of years to develop perfect, efficient organs that far outpace technology, and we are beginning to reach these artificial limits. Apart from their clear advantage in raw computing power, what really distinguishes brains is their flexibility. Essentially, the human brain can rewire itself, a feat formerly known as neuroplasticity. We see this amazing transformative feat in a wide variety of brain functions, such as the formation of memory, knowledge acquisition, physical development, and even recovery from brain damage. When the brain identifies a more efficient or effective way to compute and function, it can morph and alter its physical and neuronal structure, hence the term plasticity. Until we achieve true artificial intelligence, where computers should theoretically be able to rewire themselves, neuroplasticity will always keep the human brain ahead of static supercomputers.